Okay, today we're just going to pick up where we left off last time. Before I forget, I haven't logged it on the website yet, but I will. For next time, Thursday, I'd like you to read chapters 4 and 7. Email me 3 questions from those 2 chapters. 1 point ticket this time. Chapters 4 and 7, 3 questions. Email before class. We'll do the same kind of thing I am recording for the people that are gone. However, it's going to be a very boring visual recording because there's nothing on the screen that I'm recording. But at least my voice is there so they can hear some of the topics that we talked about today. I believe I left off on his left-hand side of the room here. Kevin, did you get a chance to ask a question last time?
Yeah.
You did. Kathy?
My question was around the nulls versus blanks.
Uh-huh.
I understand a null is not the same as the
Correct.
text. But the chart that was down below looked like they were blanks, not nulls.
Very hard to tell apart sometimes. Depends on the database program. The program that we're going to be using is called MySQL Browser, and it designates nulls as nulls. Get a little italicized gray null that tells you there's nothing in this field versus an empty string. Putting an empty string in the database, I verified this in 2 different databases. I wrote a program that generated 10,000 random records, put empty strings in a field, check the size of the database, put nulls in the field, check the size of the database, and the null values did have an effect. The database is smaller when you put null in there. What's confusing to programmers, this is not a user problem, because users don't understand null and they don't need to. That front-end program, remember that's the software that we're writing that goes on top of our database that isolates the user from the database. The user sees a text box, put in your maiden name, it's Miguel, he doesn't have a maiden name, so we just leave it blank. The question then becomes, as a programmer, do we store that as blank, as in I don't know, or do we store that as null, as in we didn't get an answer, not applicable because it's a guy? In most of the databases I've written, if the item is blank and I don't know, I store null. The author of the book talks a little bit about the differences between I don't know, not applicable, not provided, like middle initial. If we don't provide one, does that mean you don't have one? Maybe. Does that mean we don't know what it is? Maybe. How would I store that? The military is real hung up on NMI, no middle initial. If you don't have one, then it always shows up as NMI, meaning we checked. He doesn't have one. Quit asking, is it, are we missing it? Because he just doesn't have one. So in some very rare circumstances, the answer not being there, it's important that you designate we checked, and they just don't have one, so not applicable. But that's part of our job as a business analyst or the business programmer to say, we want to display NA for not applicable in here versus blank, meaning, I don't know, or not provided. I don't usually run into that. So null is my solution to an empty text box. Or if it's a combo box and you can pick from one of these choices and they pick none. I don't store none in the database, I store null value in the database because it takes up less room. And if it takes up less room with 10,000 records, it probably takes up significantly less room with millions of records and makes a difference. Database size today, not that big a deal, but there's no reason we can't be as efficient with space as possible. So when we build our databases, we'll be using null for not provided or missing or blank, unless we come across a circumstance where it's important that we say this is not applicable to this person. And we might put an NA in there. We can always do that. The other thing to be concerned about with nulls is they can screw up your statistics sometimes. But once again, that's our job as a programmer, not this class, to It's our job as a programmer to go in there and say, give me all the records where this field is not null and add them up. The only time you need to worry about adding is if the numeric field, which is rare, is null. What does a null numeric field mean? That one bothers me a little bit. How many did they order? Blank. What? What's their salary? Blank. What? Age. Give me a numeric field where missing is acceptable. Usually it's not. We want something in there. If it's missing for an age, that means unknown. If we try to calculate the average age of this group, some databases, when they hit a null, will say, well, that's infinity. And when we add infinity and divide by 50, that's infinity, so, or they'll give you null. Because null is like the black hole reverse of infinity, sucks everything up. If one of your ages in this class were to be null, then the answer, based on the database, some are different. Some databases will report null, sucks in all the other values, and the average age is null. But we as programmers, if we know that null is not allowed for the age, can write code, and we can write queries that said, only give me a list of records where the age is filled in, and give me the average. We can do that. So I have to be careful in some databases, and I experiment with usually any new database I play around with, what happens when I add up values that include a null. There's another hand on nulls. Matt, was here?
Is null and nil the same thing?
Yeah, I think so.
Okay.
It's just a different term that C# has decided to use as part of their language. JavaScript uses null, C# uses nil.
Okay.
Yeah, those two are pretty much the same.
Nil is German, so maybe.
Nil is German, yeah, I suppose. I don't even know if that's spelled right, because nil is usually one L, null is two L's, and I'm not sure if that's the German version or not.
It just kind of makes sense out of it.
Yeah. Kathy, did I answer your question? I did. Okay. Steve, what do you got?
I do have a question. About primary keys.
Okay.
The primary key is the field that is one that keeps track of that particular record. If you reuse that primary key in another record, it's somehow called a foreign key. How can
No, not in another record. In another table. Remember last time I
had
had two tables up here. Let's put them back because they're handy. We have, let's do orders and parts.
Okay.
And remember this, let's keep that one, but do my other one as well, and that's customers and orders. Now notice I've got three boxes. I've got three different tables now. These are definitely in the same database, and they're all related. Customers, place orders, parts. Right. What about this relationship? Does it exist? How are you related to the part that you just ordered? You're not. You're related because you ordered it. So there's no direct relationship here. That's one of the things we're going to have to struggle with when we finally get around to designing our database. Is there a direct relationship between two tables? Or is there only the indirect relationship, customers are related to the parts that I have at Mark Motors Parts Sort because they ordered them. Otherwise, I have no relationship to those parts. Okay. So back to customers and orders. The customer, let's say, has an ID number. And we might have an order ID number. These are primary keys. Primary keys are often ID numbers that are just made up numbers that don't mean anything, like your student ID number that we talked about last time. They're primary keys. Every order has a unique order ID number. Every customer has a unique customer ID number. That's what makes them primary keys. Because they're unique for every single record. Now back to Steve's question, how do I know who placed this order? I put the customer ID in here.
All right. So when the customer ID becomes part of the order table, it's no longer a key field?
It is no longer a primary key in this case.
Thank you.
Generally, it will not be.
But it still looks the same to me. It's just in a different table.
Sure. It's in a different table. It is the same.
Okay.
It's the same field. It has the same structure. It's still a made-up number, but
Right.
it's a made-up number that came from the customer's table.
All right.
All right, so if I want to know if this is customer Steve here, 1, 2, 3, 4, 5, 6, 7, 8, I look at this order record. I see this customer ID. If I want to know what his name is, what his phone number is, what his credit card number is, or whatever, I follow this ID. I look him up here. How many orders can you place?
Bunches.
Bunches, hopefully, right? If my business is going to succeed, I need you. So there could be dozens of orders with your ID number up. How many of you, however, are there?
Just one.
Thank goodness. Right? It's just one of you. So for every one of these orders, if I want to know who is it, I come down here and there should be one record with that ID number in this table. So I can get your phone number, I can get your address, I can get your credit card number, or your name for that matter, because I don't put your name in here.
Okay.
If we design this right, we don't put your name in here. Because if I spell Hoffenbradel wrong 40 times, I got to remember to change it twice or 40 times. If I misspell it here, it's only going to occur once, I fix it. And from then on, whenever I look at orders, it's spelled right.
I think I get it. When you're looking at one particular table, that table has primary keys, but it may also have foreign keys that were primary in another
Yes,
table.
exactly. You said that pretty quickly. I hope he understands it. So what he said is, every table has a primary key. Absolutely. Maybe you can also have composite keys, meaning two fields stuck together. We'll see. Let's leave those for later. Okay. But generally, each table has a primary key, one field, that is designated a primary key. A foreign key links, remember I don't like the term foreign key. I like the term linking field because it links, it's the field that links these two tables together. If there's a line between them, there's a relationship. If there's a relationship, one of them has to be tied to the other. And in this case, it's the customer ID. I don't have an order ID number down here. Because how many orders could Steve place? Dozens. But here's an order. How many customers placed that order? One. Okay, so this goes back to one customer. This is the foreign key, the linking field. This is the field that links these two tables together. The foreign keys are always primary keys in another table. What kind of table is this that has that primary key in it? We talked about two different names for these tables and the relationships. But remember? I know that I'm just going to keep stuffing these things into your head. When we do it for real, it'll sink quicker. I've learned that repetition is good. Child and parent. Which one's the parent here? Customers is the parent. And this one is a child. How do I know? Because the child is always linked to the parent, never the other way around. Because one parent can have multiple children, how many times do I put Steve's order in there? I don't want to do that. But one child only has one parent. The relationship here is one to many. One customer places many orders, but an order is only placed by one customer. The one is always the parent. The M is always the child. The child has a link to the parent, not the other way around. You'll see this over and over and over again and become second nature very quickly. I heard a voice over here.
So if you're looking at a database and you see that two tables share a field,
Yes.
in relational database development, it has to be the primary key.
It better be, otherwise why are they sharing it is my concern. It has to be. Okay, her question is there any way, we'll rephrase it, is there a way for this table to have the first name in here of the customer? So now we're sharing first name here. No, that now we're not in third normal form anymore. Okay, what if Steve decides from now on, don't call me Steve, I'm Steven? I'm going to have to change it every time here it occurs. Now, today that's easy, right? We don't want to. We want to change it once, here. Your last name changes. We change it once, here. From then on, whenever we look back at your records, we find all of your records, and they're all labeled with your new last name. So what we're trying to avoid here is duplicate data, right? the big push in third normal form relational databases is to eliminate as much duplicate data as we can. So for every order, I don't store the customer's address. I don't store the customer's phone number. I simply store their ID. But what a pain. What if I want to know what parts has this customer ever ordered? Then I have to go through here and over to there. Yeah, it's a bit of a pain, but that's what relational database programs do. If they make that easy. Once we've built this structure, a relational database program or management system, if you wish, allows us to say, give me a list of all the parts that Boker's ever ordered. Gross. The relational database program behind the scenes allows us to ask that question. Links all this stuff together for us and treats it, looks to us like one big, huge table. Think back to Access where you created a query and you had to bring in 3 tables, and then down here you just threw stuff in, whatever you want. A little bit of this, a little bit of that, some of these, sort by that one, filter by this table. Didn't matter. What's important is the structure behind the scenes. If the structure behind the scenes is right, and there's this one-to-many relationship with a child-parent, the relational database program takes care of the rest. Ties them together. We'll see that. Yeah, wow.
I don't know. I hope it's not a confusing question.
To me or to you?
Either one.
Yeah.
But okay, so orders now becomes the primary key, the order number, right? The
Order ID, right?
Order ID. So then when it links to the parts table,
Good. Okay. What do I have over here, do you think, for a primary
well,
key?
parts number.
A part number or a part part number.
Part
He
ID.
said order number. As long as you're consistent, doesn't matter. And actually, you don't even have to be consistent. I could call it order ID over here and order number over there, and still link them together.
So then it would
It's a
link
little
actually.
harder, a little more confusing, but perfectly legal. This name here, customer ID, does not have to be the same as that. As long as I, the designer, say, there's the link. It's confusing as all get out when you do that, but it works. And sometimes you have to. But there's a problem here before I answer your question. One order could have how many parts on it? Many. One part could appear on how many orders? Uh-oh. I can't implement that. I can design it, I can say that's, but I can't leave that alone. When I get around to actually building this database, I cannot implement that. This is many and many. Where do I put the many? Many parts on my order? How many parts? Dozens? One. I'd have to put part 1, part 2, part 3, part 4, 5, 6, 7, 8, 9, 10, 11, 12, 20 to save room for up to 20 parts on an order. If I have that many lines on an order sheet, I need 20. And if I only order 1, 19 of them are wasted. Well, because that's not a good idea. So let's go over here. How many orders does this part appear on? Thousands. That's not going to work. The solution, we'll get to this again later, is a linking table in between that keeps track of which parts are on what order and what order has what parts. There's another table in between there that you and I don't see. Now, back to your question.
Okay, now that you make it a little more interesting. So now that the orders is still our primary table.
Primary table how?
Well,
Where?
it's our, okay, we have the primary
Key of order ID.
primary key under order ID, right?
Yes.
So when that links to the customer ID,
This
Yeah.
links to the customer ID.
but when you type in the customer ID, does it list then? Will it list then the orders that are done for that customer?
That's
ID?
your program. You maybe do what you want to do. Absolutely.
Oh.
Because you're talking about the front end now. This is the database behind that keeps track of who ordered what when.
Right.
Okay. Now you've got the front end, and now now we're in the systems class. What does the user want? I want to be able to pick a customer and see all their orders. Okay. Then you have to write a form where here's a combo box. Type in spin, good enough, here's spin word, click. Behind the scenes, the program goes and gets all of the orders for Spindler, then it collects all the parts that were on those orders and displays them however the user wants.
Also, I was behind them.
So once I got the data, what can I do with it? anything you can dream up. We haven't talked about it in systems, but there's two kinds of queries. There's a standard query or a fixed query where we know at the end of every month, I want to know what was my total orders. How many parts did we sell, and what was the total price of those parts? I need to know that at the end of every month because my boss wants it every month. Then there's ad hoc queries. Ad hoc queries mean there's no way for us to predict that somebody would dream this thing up. From a front end standpoint, those are near impossible. That's why there's still database administrators and database specialists, because when somebody asks an ad hoc question, how many customers who live in Plover have ordered new bumpers for Toyota minivans dated 1997 to 2004? Sure, I got that snapped to my fingers that no. But as long as the data's in there, if you can dream it up, as long as I got the data, I can give you the answer. And that's another power of relational databases, is that we can answer questions that nobody ever dreamed up before. And when you're an organization like Lions Camp, all of a sudden the state dreams up some new statistics that they want or some new report that they want every year. Lions Camp calls me and says, quick, I need this in 2 weeks. Data's in there, no problem. The only thing that's hard is making the report pretty. Getting it's easy. Getting the data is easy. Easier. You'll learn that in this class. The hard part of this class is designing that stuff. Once it's designed, getting the data back out, which is what we're going to do the second half of this class, that's fairly simple. Fairly. So, can I answer the question this time or get sidetracked?
I think we're good.
I forgot the question, so I must answer it. Ben, you got one? No. You can say no. Sam? No. Andy? No. Joni? I didn't give you your paper back. Sorry.
Scribble.
That's it.
Or no values loaded in the database, and discussing that with business rules. I think
Say that one more time, because that goes back to the first question we had.
or no values loaded in the database.
We don't. I remember that question. You don't avoid nulls. Unless it's a required field. And you can designate that a field is required in a database saying you must put something in here or you can't save the whole record. I'm putting in the new Joni record for a new customer. I must have her first name. Or it just sits there and says, nope, can't save it. Nope, can't save it. Need a first name. Nope, can't save it. We can do that in a database to avoid nulls. In fields that we want to avoid nulls. Right. But if I want to store maiden name for him, I allow nulls for maiden name. This is a philosophy I'm going to share with you. I allow nulls in just about every field that I put in my database. Primary keys by default cannot be null. You cannot have a unique value that identifies him as null. You can't do it. So primary keys are never null. But I've always found whenever I write a program, particularly the front end, and I put a rule and says you have to give me this, they call me back about 2 weeks later, go, is there a way we can leave that blank? Because I don't know her first name right now. I got her last name, that's all I can read. Can I create a record for Joni with just a last name, give her an ID number, register her, and then fill her name in? I always get that. So I'm not a big fan of not null fields. And I also don't put the required thing in the database. That's a business rule. This is required. That's a business rule. It doesn't go in the database. It belongs in that front end program that has all the rules in it. So when I need to change the rules, I change it here, not the database, in the program. In the programming logic class, I showed you this 3-tiered model that almost looks like a database, but it's not. And over here, I have my database. And over here is my GUI, my graphical my form, right? My graphical user interface. Start doing forms today? In the beginning?
Yeah.
Barely, okay. In between is a business class. Those of you in intermediate are going to see that Thursday. Okay, we're going to start working with that business class. This has got all the rules in it. It's the only place I put rules. I don't put rules in the database. You can use, you saw it in Access, right? There were just a couple of questions, if I remember right, where you could go in and say that the validation for this field is it has to be between 5 and 20, or whatever they told you to make it. You can do that in Access. I never do. Because I don't want my users going into the database. Because when users go into the database, they're going to mess things up. I want them using my GUI that knows the business rules, and the GUI said between 5 and 20. The GUI does. So when I keep talking about this business class, it's between our database and the user. This is the little curly brackets. Luckily, most of you are here now, so I don't know. I think Aaron's still missing, but hopefully he'll listen to this. This is kind of what I call the front end. Sits on top of that database. The user never directly manipulates the database. Lions Camp is built around Microsoft Access. I told them if you go into Microsoft Access, my feed just went up 100 to 125 an hour to fix whatever you mess up in there. They won't touch it. If the program doesn't do what they want it to do, they call me and say, make the program do this. And I go, okay. Only $75 an hour. Right? But if you mess up the database, it could take me a long time to go figure out, first of all, what's wrong and then fix it. I don't want them going in there. This supports this. This is what they see, is this. They don't even know about that part. This, the GUI, is all they see. Those forms that you created last semester, you'll create again for the rest of your life. Programmers. That's what they see. Everything else is technicalities that you and I have to take care of. Yeah.
Sorry, this actually was one of my questions too, sort of what you went to now.
Go ahead.
My question was in reference to the data integrity.
Okay.
How does someone know that's maintaining the database if the data has been, or if the data is inaccurate, or if the database has been changed? And how can a database be fixed if the data has been compromised?
Okay. First of all, how do I know that the data is bad? It's impossible in some circumstances. Numbers, pretty easy. I need a number between 5 and 20. If the rule is I need a number between 5 and 20, the user never types anything here that gets past the century that get in here with a number other than 5 and 20. The front end takes care of that. On the other hand, I spell Spindler with 2 L's. Happens, right? Volker with an extra couple of E's in it. It never happens, right? Volker is my last name, Gall is my, okay, that's an error. How do you avoid that? How do you make a program that's smart enough to say Spindler's only got 1 L in it? Because tomorrow we'll find a Spindler with 2 L's. Or we went to dinner to Michelle's last Friday, my wife types it in with 2 L's. And then she gets the receipts, only 1. How do you avoid that? How do you write programs smart enough to say when it's the restaurant it's 1 L, but if it's the girl who's sitting in the back row, that's 2 L's? You can't. Think addresses. Cities, maybe, but you'd have to have a huge support database. Say, here's a list of all the cities in the world, and it better be on that list. That's huge. Most of the time you don't do that. So then what happens? Somebody types in Stevens Point with a space, somebody else types in Stephen Point, somebody else types PT, somebody else types it without the space. It's near impossible to ensure that your data is perfect. How do you fix it? Well, I call up and say, Volker doesn't have an E after the O. And they go, oh, I'm so sorry, let me fix that. They go into here and they say, go find Volker. How? Combo boxes, I don't know. They might ask you your phone number. Right? That's pretty common. Why? Why do they want your phone number? It's not unique. Because they're afraid to ask you because Volker said it's really stupid to ask you what your customer ID number is, because you probably don't know anyways. Oh, well, if you look on your latest receipt, I don't have that anymore. Oh, okay. What's your phone number? It's the latest thing I'm hearing all the time. Because these cell phones have almost made that unique for you. There's still some old folks like me who I don't share my cell phone with my wife, but my mom and dad do. They share one cell phone. So that won't work for them. But on the other hand, my dad never orders anything because he always messes it up, so he lets my mom do it. So it's all under her name, one cell phone.
Can't you just like have it to ask like the number and then also ask the names of the
Well, all I need is the number, right? And if I get two people with that, I can listen. If it sounds like a Lori, that must be my mom. Right? Sounds like an Eckhart, it must be a he. And I can sort that out. And that's what I wish they would do at the front. No, let's go. I'm not getting on that soapbox again. Did that last time. Right. But that's why they ask you your phone number, especially if your name's messed up. Couldn't they just look for first name equals VOELKER? There might be a bunch. And if they're not smart, they'll check the last name. There's a bunch of those with an E in. But then, once they find me, here's everything we know about Voter. Fix the spelling. Hey, well, I got you on the phone. Your address still this? Yep. Phone number still this? Yep. Zip code? Yep. Still born in 1958? Yes. No, that's changed.
a long time ago.
Shut up. Right. So, yeah. So we can fix errors, but the trick is finding it. Somebody's got to report it. You get statistics at the end of the year, and you go, that doesn't sound right. Pam spent $10,000 on Mountain Dew this month? Somebody forgot a decimal point. They were typing. Well, that sounds like a pretty stupid program that lets me type in $1,000 worth of Mountain Dew in a month instead of $10 worth of Mountain Dew in a month. So maybe then we tweak our business rules. It's an ongoing process. But at some point, your program is as smart as it's going to get, and it's up to those humans to enter accurate data to ensure data integrity. It's up to the humans to ensure that. And if there's an error, your program has to allow them to adjust it. And they can. And so Pam calls and says, what's this bill for $1,000? You say, well, that's what we got here in my database. I didn't order $1,000 worth of Mountain Dew. Do you have a receipt? Sure. What does it say? 10. Oh. Is that the order that you placed on December 27th? Yep. I see it. Here it is. $1,000. Let me fix that. 10. Done. We can still make mistakes, but we try to. This is part of why we're doing it. Just try to avoid as many of them as we can. Unit 2, Programming Logic Intermediate, we're going to spend, and from then on for the rest of your programming life, validation. What are the rules? How do I catch it? What do I do? John?
So is the business class metadata? That's its parameters?
Kind of. That's an interesting term, metadata. What does she mean by the metadata? The rules here, and why is it 5 to 20? Where do I get those rules? From the user? Do I hard code them in here with constants? Or do I put them in here in another table and suck them out of the database and say, here's the rules? The advantage of putting them here is I can add more stuff to this to say the rules have changed, it's now 10 to 30, and the user can do it without me having to modify the code. But it adds a big level of complexity to give the user the ability to change the business rules. We'll leave that for some other day. But yeah, in a way, this is metadata because I'm hard coding the 5 to 20. There's some data. What are the limits? Or I can put it over here, and there's no data here, which is probably better. But
Does that also include something numeric, alphanumeric?
no, that has to be done in the database, and it has to correlate here. Because if you say it's, and I've seen this, everything's text, I don't care. It's a number, so it's text. In the database, it's text. I think, actually, in MySQL, we tell it as numbers, but it's really text in the actual database, and then when it comes back in, it's automatically converted to a number for us, I think. But most database programs like Access, remember when you were designing tables in Unit 2, you had to say this is text size 20, this is a double, this is an integer, this is a Boolean. Those data types are defined here, and then they track to this. If this is well designed, how could I get the wrong type? Not likely. If it's well designed, then the business class is, oh, that's text, oh, that's an integer, or whatever, and it flows well. So they correlate. That's why there's a link here. But notice there's no link here to there. Not directly.
Sorry, I got one more.
Oh.
And then I'll stop.
No, you don't have to because they're good. Keep going.
No, is the business class then behind the scenes of the GUI?
Behind the scenes, it's a separate file.
It's a separate file. Oh, so it'll be a file that we bring in.
It's a separate file. When we talk about custom classes, that's what's in the business class. The custom class has all the information that we need for processing anything about customers. There'll also be a business class for orders. There'll also be a business class for this little guy that we haven't even given a name to yet. There'll be a business class for this. There'll be 4 separate files for these 4 separate tables that contain the rules for each one. Now take that to Lions Camp. Well, right now I think there's 33 tables. 33 business classes. Where's the code? Oh my God, it could be in the GUI, it could be in the business class, and you're going around and back and forth. After a while, you focus in very quickly on where are the issues. The really weird stuff is what happens when you write a report that uses information from here, here, and there. Where do you put that? Here? There? That's the hard one. Occasionally, you've got stuff that overlaps. You got to put it somewhere so you can find it. It's a bit of a challenge. Okay, I think I made it around the room, so now it's open season. What else you got on your list? Burning questions. Don't be shy. Otherwise, I'm going around and asking you again. Lyle's doing good, but he needs a rest, he said. Yeah.
Do composite primary keys make data more difficult to query or otherwise limit the query function?
Do composite keys. What's a composite key? As it turns out, the key for this little guy here, and by the way, the hard part of database design is coming up with a name for that. What do you call it when you link orders and parts together? You got to give this a name. And Hernandez would say, call it the ordered parts table. Sometimes that's all you can come up with. You just throw junk together. Does it matter? Not really, because the user never sees it, because now we're back talking about this thing again. The user never sees it. I don't care what that table's called. To me, I picture a piece of paper that lists the order that I place. And so each one of the items that I order is an order line. It's on a line. So this is my order line table. You can come up with a name, that's great. That's my order line. There's one line on an order, it's got some stuff filled in for the part. Turns out the primary keys for the order line table are the order ID and the part number. 2 keys. Composite key. A composite key is a key that is made up of more than one field. 2, 3. If it gets to 4, I won't do that. It's another solution. Artificial key. You'll hear that one every now and then. What's an artificial key? Most of them, numbers that I made up that don't mean anything, just uniquely describe this record. Do they make it harder? Her question is, when I have these composite keys, do they make it harder to query the database? Not for the user, but for you and me, the poor schmucks that got to write this code to say, go get me all the parts that were on this order. Okay, a little bit. It's like saying, is it harder to create a form with 5 fields on it or 20 fields on it? 5. No, it's not harder, it's just longer. Right? Because there's 20 fields I gotta create, the text box, I gotta line everybody up to make Booker happy, and it's just longer. You can be well paid, who cares if it takes longer? Sort of. You also have a deadline in many cases, so you have to be as efficient as possible. But it complicates things. Yes. Especially if there's 3 or 4, then it's just crazy. Come on.
On page 31, when Dennis is going through the objectives of good design,
Uh-oh. Okay.
his last one is the database lends itself to future growth. The database structure should be easy to modify or expand. And I was wondering if you could give an example of a database that wasn't easy to modify or expand.
Heck no.
To me, you could expand anything sloppily
Yes.
or add fields onto anything. I don't know how a database can close down expansion.
If it's not third normal form, it can help. Can I give you an example? No, because all my databases were designed from the ground up to be third normal form. Okay. Good database design starts you off in that ultimate goal of third normal form. And it's not even ultimate, but it's a nice target. You can remember there's 4th, 5th, 6th, and 88 normal form or whatever they call those other ones. If it's third normal form, you probably got a pretty good database. If I wanted to add to this now, I've got customers, orders, and parts, and now I want to keep track of my salespeople. Who sold this? Do we have to start over? I hope not. Probably not. So now I have to, as a database designer, decide. And how do I decide? By talking to my owner. Where do those salespeople go? Do they connect to orders, or do they connect to customers? It depends, right? Depends on the business. Maybe my salespeople have customers that they're responsible for. If that's the case, I go this way. If that's the case. If my salespeople are just answering the phone and whoever it is, they take the order, then it goes here. One salesperson takes how many orders? Many, or we fire them, right? One order is taken by how many salespeople? Probably one. How can I have 2 people on the phone? No, not at the same time, but I might get a different salesperson when I call in and complain about my order, or say, I just placed this order 10 minutes ago, I want to add something. Is it too late? No, go ahead. And now a new salesperson takes over. How do we deal with that? I don't know. I'm not the owner. One of the things that frustrated this last group that took this class was that I had all these artificial rules that I made. Well, yeah. If we make real databases, they're so big we can hardly talk about them in class. So I put some rules in. I'm the owner. And if you're not sure, your job, systems analysts, is to ask me. Do you make assumptions? That'll work for a while, if you're right. If you don't ask me and you make assumptions, your answer's got at least a 50-50 chance, probably worse, of being wrong. Gotta ask. Particularly in this class, we're trying to scale things down so we can learn without getting buried in the details. Astonished at the program that they were asked to do in systems design, or the database design they were asked to do. It was this huge, they were in here, had this board filled, and they wish they had another one, full of these boxes all linked together. Hard to do, especially when you're just starting to learn. Trying to keep it simple. This is this 4-1 here is pretty classic. Learn how to get your head around databases. Because most people can relate to customers and orders and parts or products or whatever you want to call them over there. Most people can relate to that. But you can see what happens when we add one more table to it. But back to Karen's question, how can I screw this up? If you build it right in the first place, you can. Should be able to add. If you're not careful when you add, like if I connect this to the wrong one because I forgot to ask the owner, I said, well, that must be part of customers because salespeople only have their own customers. Not here, they'll share. The sooner you get the design right, the sooner you can get the business class right, and the sooner you can get the GUI right, because as soon as the GUI's done, then you can deliver and say, here, use this. Your database is screwed up. Your database design is wrong. Your business class is going to be wrong, and your GUI is going to be wrong and reflect it. That's why we start with this class in this semester. I almost want to start with it before systems. Because data is the foundation of all this. I firmly believe that. Gotten into arguments with Sean and Jason, who teaches the other systems class, about, well, no, we can do prototypes, right? Sample screens. Okay, this prototype looks good to my user. What's the next thing I do? Take all that stuff and say, I need that data. Build a database to capture it. So the next thing I can build prototypes. That's to collect the information that I need about what kinds of data do I need to store. So kinda I can do storyboarding and say, here's what the screens are going to look like. The ultimate goal that I still think is the data. That answer? Not very well. Can you give me a bad example? No. I don't have any. I don't do those. And you'll note in Hernandez's book there's no bad examples either. There are very few of them out there anymore. I would guess as databases get complex, hundreds, thousands of tables, Centric, Skyward, Renaissance, thousands of tables, and you can screw that up if you're not careful, but that's why there's people called DBAs, which means, stands for Database Administrator. Their job is nothing but make sure as people don't put stupid things in this database. Their job is somebody needs this data in the database. Where should it go? Sometimes it's very obvious. If I want to store somebody's birth date in this database, it's probably going into customers. Why would I put it anywhere else? But that's what the database administrator's job is. I'm going to change our database, add new data. He, she will figure out where that goes. Or whether it's already there. Thousands of tables. How would poor Tyler know without going through all the thousands of tables that that data's already there? He just didn't know where to look. Tough job. Very difficult job. And maintain everything in third order normal form so we can add more stuff. And don't forget the data integrity. And he forgot to ask about referential integrity. Remember that one from Access? The little checkbox. Ta-da, done. What does it do? Referential integrity. I think I mentioned it last time briefly. Referential integrity says there shall not be a child without a parent. I cannot have an order whose customer doesn't exist. Does that mean I keep my customers forever? There's some businesses around here 120 years old. I'm sure their original customers don't exist anymore, right? Doesn't mean you can't get rid of your customers, though you might want to archive them. I'm not a big fan of deleting data, unless it's wrong. I have a customer. He hasn't ordered for me in 20 years. Okay, what do you want to do? Delete them? Okay, what happens to all the orders then for that customer? Referential integrity says I can't delete the customer without dealing with their orders somehow. Well, that could be deleted. Because now I've lost my historical perspective, and most businesses care about that at some point. But maybe after 30 years, they don't care. What did I sell in the year 1990 something? Who cares? 80 something. Who cares? Maybe. Most businesses care. They want to show their growth, right? Well, how do they know their growth? Maybe by keeping their data. All of a sudden, the new president comes up with questions that nobody's ever asked before. We still got all the data. We can answer them. Keep our jobs. I like archiving. Put a little checkbox in here, say current customer or archived. Check. And then when I ask for a list of customers, I don't get the archive. They're hidden. I'm looking for statistics. I don't include archived customers. The other alternative is we delete the customer and the orders, we assign them to a dead customer file or whatever. One record that we keep in our database that designates our customer no longer exists. It's not dead, but deleted customer. So we have a customer, number 99999, who is our deleted customer, and any orders for customers that we deleted get assigned to 999. That becomes the new parent. Referential integrity, the important part there is no child without a parent in the database. It'll probably never get hit. But if it does, and I say, give me a list of all the orders from February 1992, and then we go looking for the customer, and the customer isn't there. Uh-oh. How does our business class, how does our GUI deal with the fact that there's no parent? If we say there will always be a parent, we don't have to worry about it as a programmer. If there's thousands of tables and I don't have to worry about a missing parent, that saves me a lot of code. No lies, that's cool. Go.
Does the customers then, if you archive the customer, does it get its own table? You make it an own table for it?
That's another
Does it
option.
go behind the scenes?
So another option is to create an archive customers table, which is a separate one, but that adds a little complexity because then if I'm looking at an order and it's not here, then I got to write code to say, well, if you can't find him here, then go over to the archive customers because he's probably over there. What many businesses will do is, and Lions Camp, they do donations too. Their donations table, what they do is anything that's more than 10 years old, once a year, they take all that data and they copy it to an archive database. It's a duplicate database, but this is current and this is old. Okay, and so they move all the customers and the orders. Any customer who doesn't have an order before 10 years, so that would be 2005. The orders for 2005 and before get stuffed into a database. And any customers who don't have any orders left, this is legal, by the way, one customer with no orders are potentially archived as well. When you do that, then you got to think about, oh, I'm back. It's been 15 years, but I'm back. Do I create a new customer for you? No, now you got to write code. Let's make sure there isn't a Volcker call in the archives. And if he is there, pull him out of archives, put him back into active, make sure all his data is accurate. And what? Bring all his orders back from 15 years ago? Maybe. But if the answer is, nah, those orders are too old, well, then I have to keep a customer old Volcker and a new Volcker. Like I said, real world databases get much more complex than you're going to see here in this. Joey, it's almost there. Spit it out.
Yeah, no, I'm just thinking if you deleted a customer, the parent, why would the order be deleted also?
Historical perspective, I don't care who ordered it, but I want to know that I sold 100 of these things in the year 1971.
But I'm just thinking if you deleted a customer, because the order is the child, I think that order would be wiped out too.
It can be done automatically. Access will do it automatically. That's dangerous. Because now you're wiping out
I know
historical
you
data.
don't want it deleted.
Right. That's why I don't turn on referential integrity and access. I disagree with your access book. But your access book is not teaching you to use access with a front end. It's teaching you how to bury down into access and dig around in there with the data and generate your own information.
But what if you use order as the parent?
Can't.
Because each order is
It's not up to you to
unique.
pick a parent. It's how the database works. I can delete orders,
Then you could delete
but there's a risk to that. Okay? You have to ask your order, your owner, your customer, all right, I'm deleting your user, I'm deleting a customer from the database. What do you want me to do with their orders? I'm doing salespeople up here. Pretty good chance we're going to delete salespeople. They're going to leave, right? Can't be a good job. That's not a good job. So I'll do it for a while, get experience, move on to be a supervisor of salespeople or something. But now they're not salespeople anymore. Do you delete them? Probably not, because 2 years from now I call about an order and question it, and they say, who took this order? He said, oh, he's a supervisor. Let's go ask him. Deleting is just, it's something you have to consider when you design systems. How do I delete data? How do I archive data? You can create a separate table, or within the same table, I have in my customer record a checkbox at the end that says archive. And And then I can ask questions like, only show me current customers where the archive bit is false. The checkbox is still off. I don't want to see the other ones. And they're all still in the same table. Oh, that's going to take up a lot of room. The stuff we're doing, so what? For Amazon, it's a different problem.
So how do you populate that archive box? Who does it at what stage?
Somebody says, with clicking on a button on a GUI form, on a form, says archiving. And then behind the scenes, my business class has all the rules for how to archive stuff. And we have to write code to make those rules happen. So that when you delete a customer, we go find all the orders for that customer. We copy them into the archive database, writing code. When we're done, we delete the originals. If there's anything else linked to orders, now this is just one simple thing, customers to orders, but if I delete a customer and they're tied to 6 other things, oh my God. Then I gotta go delete that one there, this one over here, this one over here. A customer table could have 5, 6, 7 child tables. Good. See it. Then what? Think campers at Lions Camp. There are all kinds of child tables. Who are their guardians? Each camper has one or more guardians. Now in this case, parents turn out to be the child table. They have lots of guardians. Which years did they come to camp? So there's my attendance program. There's my attendance table that is linked. One camper has many attendance records. Medications. This camper takes medication. One camper takes many medications. So now I want to delete a camper. Oh boy. This camper's deceased. They do. Do I want to delete them from the database? They're deceased. Lions Camp? Don't do it. Just archive them. And there's actually another checkbox that not only are they archived, but they're deceased with sending them mail. It bums people out to get mail for people on around. But they still keep the records. They were there so that when the state asks, why should we throw more money at you? They can say, well, look, since 1975, we've done this. Or whatever. So there's really no straight answer. But when the user's involved, because the user has to say archive. Even if it's anything over the year old, archive. You don't do that every day, John. There's this magic day, January 15th, March, June 30th, whatever. And some administrator of the database, meaning administrator who has more power than some data entry person, sits down and pushes the button that says, nuke them, archive them, and then the program pops up and says, you sure? Yes, I'm sure. Enter your ID number and password 6 times again to be sure, because this is some dangerous stuff. I want to make sure it's really you. They pass the test, and everything happens automatically. Users don't do it. They just say, give us the instruction to do it. And it happens. I think, if nothing else, you're starting to see the potential complexity of this stuff. You don't just have this database. Well, actually, you do. Most of you, when you get your first programming job, there's going to be a database. And your job is to figure out how all those 1,000 tables are related, how are they linked together, which data is in what tables where, and start dragging it out of there when you need it for the programs that you had. But some of you, like me, will write programs for yourself, and you'll have to build your own databases. In the programming section in the afternoon, Nathan Wergen's in there, he makes his own beer. And I said, well, you could write your own beer management database. He started drooling right away. Oh, that would be so cool. You're going to help me? Yeah, I'll help you. You're going to write it, but yeah, I'll help. So yeah, in programming logic, I'm giving you the option to build your own program instead of my boring ones. If that's the case, you got to design your own database. If you do consulting work like I do, they're usually small little programs that I grab hold of. But they still have a database. It might be 10, 15 tables. I got to figure out which tables they are. That's what we're learning how to do in the first half of this class. How do I know which tables are there? How do I know which fields go into what tables? How do I know which tables are directly related and which ones are indirectly related? That's where we're headed. get some terminology, some thinking, thought process out of the way. That's what today's about, and Thursday as well. And there's 2 more chapters. I can tell some of you getting itchy. Come on, let's do this. Sounds fun. Yeah. Anyway, particularly when it's done. Process sometimes. A couple more minutes. Any more?
What's the difference between redundant data and duplicate data? I mean, it just implies it's two different things.
Duplicate data means I have 2 copies of the same data. Like 2 Karens, one Zillow, one Zillow. Okay, I've got 2 Karens, same person. But my database doesn't sense it. Right? Because both of those last names are acceptable to the database because they have 1 character or more. But it's the same person. It's you getting the catalog 3 times, right? Twice. Figgy's catalog 3 times. Every time they send me one, I get 3. Why? Something's changed, and if you call them and say, I'm getting 3 copies of the catalog, they go, oh, thank God. Oh, thank you for calling. Here's a $5 gift certificate. Now let's fix this. It was costing them money. And it's screwing up their statistics. So to me, that's duplicate data. You're in there twice. You absolutely want to avoid it as much as possible. Redundant data, very subtle difference. Here's Karen's customer ID, 11111. Here's Karen's customer ID, once again, 11111. The only redundant data we should have. It's in 2 places, but I need both. The only redundant data we should have are linking fields. Linking fields are the only fields that appear in more than one table in the database. They're the only ones. First name only appears in 1 table. Okay, customer first name only appears in 1 table. You might have a salesperson first name, right? Is it legal to have first name up there and first name down here? Confusing sometimes? But legal, because they're 2 different tables. That's the first name in the salesperson table. That's somebody different than the first name down here in the customer table. The only, to me, is a real subtle difference. The customer ID appears in 2 different or more tables. So it's redundant, but not really because it's used for linking. The more I think about it, redundant, I think Hernandez might be thinking of redundant and duplicate the same way. Maybe I'm making stuff up. That's the hard part of this. Sometimes make stuff up. There's no test. Your homework assignments are going to be ultimately create a 3rd normal form database. There's going to be fields that appear in 2 tables. Is that redundant? No, I don't know. Maybe not, because one's used for linking, the other one's primary key. Oh. Fuzzy answer. But I definitely don't. I want to avoid that duplicate data as much as possible. Remember when I was thinking about putting Steve's name in here for the orders? Well, Steve has 45 orders, and if his name is in there 45 times and something's wrong, or his phone number in the order, uh-oh, because his phone number is a little more likely to change, right, than his name. If I put his phone number in there 44 times and he changes his phone number, I hope my program's good enough to go into that table and find his phone number and change it every one of the occurrences that it shows up in. If I don't have that duplicate data, I don't have to worry about it. We avoid duplicate data to avoid errors. We avoid duplicate data to simplify programs. That is not our ultimate goal, though. Simplifying programming is not our goal. Will be well-paid programmers. If your life is not simple, who cares? As long as the design is good, flexible, so we can add to it, do some things. I can easily add fields. If I forget the archive field in the customers table, the only thing I have to think about is, okay, where am I going to put this? One of my customers is archive. Normally you fill out a form, send it to the database administrator, and they send you an answer back saying it's in the customers table. Good idea. We want to avoid that, but that doesn't mean programming is simple. So if I collected all of your questions now and put them on a test, you would all pass. I'm not sure I would, except for the made up answers. Going once, twice. I think I gave everybody NQA cards. If you didn't get some coming in, see me on the way up. And most of you will see, what, half an hour? Some of you, half an hour. Oh, who am I not going to hit anywhere else? Well, let's do it real quick since I have time. Midstate is once again sponsoring exchange with Germany. We have a school in Germany, Max School, that we do student exchange with. We are sending 6 business students this year to Germany. Your airfare is covered. Your room and board is covered because you stay with a host family that treats you like royalty. Almost said princess, right? Like royalty. They feed you. They take you out. You want to buy them a beer. They say, "Oh no, you're my guest." They buy the beer, food. The costs that they list on here. You need travel insurance of $100. You need a passport. If you don't have one, that'll cost you another $100. And what I usually tell my students when I go is, if you got $500 to spend while you're there, you'll probably bring some back. For souvenirs, your host is one of those weird ones. You force them to take a beer and they actually take one. They don't pay you back for it. My son went and he came back with 150 of his 500. And everybody who's ever been on this trip behaves themselves. Loves it. As you get a perspective of Germany that you will not get if you go over there by yourself and take a bus tour or stay in hotels, live with these people, hang out with them for a week or so. And it's like nothing you'll ever experience again unless you do it here. But most people don't have that opportunity.
Is that during spring break?
This is roughly spring break. I got to check spring break. It starts on the 15th and come back on the 26th.
Of May.
Of May. Oh, it is May. It's not March. Okay, so it's the end of the semester. This is the day after the semester ends. Boy, that sounds even better. I forgot that they moved it. Used to be spring break. Unfortunately, in Germany, it's the same weather as here. It could be snowing, probably going to be raining, and definitely not going to be the year I went. It was 7. I couldn't believe it. It's because I went. They wanted to come back. But in May, you're much more likely to have nice weather and enjoy your trip and be able to hang out outside instead of inside. So that's actually better. About a 10, 11-day trip, which is just about right. If you're interested, these are the applications. If I run out, I'm sure I can get more. You have to go through all kinds of rigmarole, like write a 500-word at least essay on why you want to go, and you are a representative of Mid-State Technical College. I know where you're from. And not only that, it's your job to fix the ugly American perspective over there. It's still there. We're fixing it, but you got to keep it going. Don't screw that up. 500-word essay, and you need 2 recommendation forms from instructors. Sure, I'll do one of them. Let's talk. No, I'll do it. So if you're interested, they're up here. If I run out, I'll get more. Questions about that? PSO, I haven't heard from some of you Friday. If you're not going, at least let me know. If you're going, definitely let me know so that I can order food for you. Second year classes requested pizza. I'm looking into it instead of sub sandwiches.
What? Sounds better.
Nah, unless it's your 4th PSO and you've had subs every time. This time it's something different.
Every meeting that
You can have pizza any day though.
everything in the IT department.
If
meetings
subs
is
are
subs.
Any other questions? Okay.
She gets some